Our first speaker, David Fahey, is the Director of Chemical Science Division at our NOAA laboratory here in Boulder. He joined the laboratory more than 35 years ago after receiving several advanced degrees in physics here in the United States. So David is a scientist I've known for many years. My background and my work is in atmospheric sciences, and I am just extremely honored and pleased that he's able to join us and share with us his, his overview of how things are going with respect to climate and what we're learning about the role of climate in many of the weather phenomena that we've been seeing. And he will also be providing his reflections on challenges ahead. So David, come on up. He's received so many honors. I don't really want to name them all, but there are many, many, many honors. Welcome, David.
Well, thank you, Paulette. It's a pleasure to be here to talk to this very diverse group. When Paulette calls you, you tend not to say no, or more particularly, you tend to say yes to her request. So she asked me to talk about climate change, current and projected impacts on the United States. And for this group, to me, it's somewhat the hidden variable in the sense of we don't talk that much about climate change and solar necessarily in the same sentences. That solar is it's kind of its own thing, that if you're pursuing solar energy, as these posters and the people in this room suggest, you don't always have to talk about climate change. It's there, it's the foundation, and I'll make that point later. And it's a common denominator for this diverse group, that as Carly pointed out yesterday, there's a lot of diversity in here, scientists, technologists, engineers, NGOs, et cetera, but all have this common theme of climate, of solar, and climate change offers a commonality amongst this diverse group. So secondly, the way I'm going to approach this today is mostly talk about the Climate Science Special Report of the 4th National Climate Assessment, which may be the most important document you haven't necessarily heard about, or if you did hear about it, you don't know exactly what it is. And I assert today that this is a very valuable document for this group because it's a way of capturing, so to speak, climate science, in particular how it might pertain to those who want to advocate for more solar energy in our nation and in the world. Okay, so I'm going to go forward and talk about the Climate Science Special Report and then segue into some other aspects later. So, Climate Science Special Report was managed by the U.S. Global Change Research Program, which is attached to the Office of Science and Technology Policy of the White House. So it's right up there at the top. It's volume 1 of the 4th U.S. National Climate Assessment. So there's been 3 before this that maybe haven't got your attention either. In fact, there should have been more national climate assessments, but people kind of forgot to do it. The climate science, the special report comes out of a mandate from Congress to produce a comprehensive and integrated United States research program that will assist the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of climate change. Very sensible sentence. I'm not sure where it was written, but it was decades ago. And so this is translated into write a report, more like a medical checkup for the United States for climate change. And so US GCRP manages this. I was selected as coordinating lead author as one of 3 federal employees to lead this report, since it's mandated by Congress. That's partly what we do, or one of the requirements is to have federal authors. Don Webbles of the University of Illinois was kind of the spiritual leader of this, and Kathy Hibbert of NASA was also on our team. There was a lot of discretion of this team to decide what it was going to do, how it would achieve this mandate. So the size, scope, time, and content of this report is really kind of author-driven. I call it kind of a bottom-up. But perhaps the most important aspect of this report are those 13 logos on the bottom. That this report was approved not only by the White House, but 13 U.S. agencies of the U.S. Climate Change Research Program. And so, and you can look across there and find your favorite agency. And so this is the nation talking to the nation and reviewed by the nation. And so that's what gives this report its real clout, that the content of the report isn't that different, as you will see, from the International Panel on Climate Change, the IPCC, that does this for the globe and does it on an international scale. But here, the United States has approved this and has said, this is important to us. Other distinguishing features, the author team has 32 climate scientists from around the US, federal labs, academia, and 19 others serving as contributing authors. The review process was highly open and transparent, another really important distinguishing feature. This wasn't done in a dark back room. It had 6 review cycles, which if you're an author is, you might describe as tedious. But part of that is just to make sure that everybody buys into what's stated here. And these reviews are part of the documentation of this report. It included a public review a year into the report. Very importantly, it included a review by the National Academy, which does things in a very serious way. It was probably our best review, where they assemble a separate panel to look at this. And then 13 government agencies, as I pointed out. And then there are these details like the weighting of results. If you go down into the technical details, how do you know the temperature changed and where did it come from? What are the levels of confidence? What's the quantification of likelihood? This is currency in the scientific realm, that saying a scientific statement today without a weighting, confidence, quantification, uncertainty really is somewhat a meaningless statement. And this traceable accounts, where did your stuff come from? So this report does this, dotting the I's and crossing the T's. It's a clean report. There are no policy recommendations in this report. Much like the IPCC, they don't cross the line. And so this makes it a more valuable report in my mind, that there are other bodies, there are other processes to create recommendations from scientific information. And this report stays strongly anchored to the science. And then from a diverse group like this, it's really, I would say, a very accessible report that has 15 chapters. It's a 500-page report. You're not going to read it all. It has a lot of good graphics. And very importantly, it has an executive summary. That was the cover that I showed up on the first graph. That's really very, very well written for non-specialists as well as other scientists. And it has some report highlights, as we'll see here in a moment. And it has a great interactive website. So I urge you to go look at it. This report, in my mind, is changing and has changed the U.S. conversation about climate change. It's the nation talking to the nation. It has all the stamps of approval that you might need. And so it's really one-stop shopping. And its permeation or its penetration into the U.S. Society will be where it really adds value to a lot of discussions. Like as I began this talk with, changing the conversation of this group. If someone asks you, why are you pursuing solar energy? Why do you think the nation needs it? Why do you think the world needs it? You can hold up this book and its results and say, this is why. Even though the word solar energy doesn't appear in this report. I actually searched for it last night to make sure it didn't. The word solar shows up a lot, as you might expect. So even though it doesn't directly address solar energy, it's very relevant to this group. Okay, and I'm not going to take you through all of the aspects of this report. There's not enough time today, and I don't think there's a need. But I'll show you some of the nature of this report and urge you to go pursue it as you need to do it. Here are the chapters. There's 15 chapters. Look at the vocabulary. It's all very reasonable. stuff that you might expect. It starts with introduction, has physical drivers of climate change. I actually wrote that chapter that says, how does climate change come about? Detection and attribution, climate models, which we depend on a lot, climate variability, temperature, precipitation, droughts, floods, wildfires, extreme storms, changes in land cover, the Arctic, sea level, ocean acidification, mitigation, surprises. So that's a pretty comprehensive list. And so I urge you to pick a topic that you might be interested in and drill down and check this out. So those of you who don't have time to read a 30-page executive summary, we made a 2-page executive summary. So I maintain that if you're sitting down for lunch with your sandwich, that you can read through this before you finish your sandwich. So there's really no reason not to read this. And again, it'll seem familiar to you, and it won't be necessarily the latest. I mean, it's not charting new ground. It's really kind of anchoring the nation in ground that we already know. So I'm not going to read this to you. That red text there is my addition to it. It's a triple executive summary. So we go down there and we talk about the warmest period in history, humans as cause, especially greenhouse gases. It's very interesting. I mean, there's a very explicit statement that humans are the cause of climate change. And if you go back and look at the reviews that we received from the 13 agencies, as far as I remember, no agency challenged that particular statement. It said, oh no, humans are indeed not responsible for climate change. So there's kind of this alternate universe where if you go down to the bottom where formality and detail and authority matter, these statements survive. Many global changes occur, sea levels are rising, it'll continue to rise in the future, heavy rainfall, heat waves, forest fires, early spring melt, etc. Future climate depends on greenhouse gas emissions. We all know that. Unanticipated changes are possible, almost certain in some respects. And greenhouse gas emissions remain high, meaning it says we're on a high trajectory now, as you'll see here also in a moment. So you could put emoticons next to all of these little sound bites, and I didn't bother to put the unsmiling ones next to all of these, but there is one smiling emoticon that still stands from this list, and that's the one that says with significant reductions in emissions, the increase in annual global temperature could be limited to 2 degrees C or less. That says that the door is still open for keeping the planet cooler than 2 degrees above pre-industrial. The door is closing, it's in motion, but it's not closed. And so this group is part of that solution. This group is part of the reason that we may keep the door open in the future. Okay, this is a collage of all the figures in the executive summary, a 30-page document. We consider them rather canonical. I urge you to browse them and read the captions and read the bullets that are attached to that. So this is part of our communication. It's not a dry scientific document where you have to be a scientist to understand it. It's really meant to communicate. And so if you look, for example, temperature, very significant, highly confident information about temperature. Here's annual temperatures over the contiguous United States. Annually, average temperatures have increased by 1.8 degrees Fahrenheit. This shows you where they've increased and the gradients that might be there. So that dark red is greater than 1.5 degrees Fahrenheit compared to in the last few decades compared to the early decades of the 1900s. Rather sobering, although if you're in the southeast, life might not have changed so much. Exactly why that's occurred, I'm not sure the scientific community understands yet. You can look at winter and summer and see some differentiation. On the right there is projected temperatures. The top two are the mid-21st century and the bottom two are the late 21st century. And look at that color scale. If we stay on this, what's called RCP 8.5, which is business as usual, emissions to the end of the century, we're talking well over 10 degrees Fahrenheit increases in the highest latitudes. as well as substantial, most of 10 degrees in the contiguous United States. So here's the medical checkup. You've been smoking, this is what's going to happen to your lungs. And so this is still why the door is partly open, is because we think there's a chance you can avoid this fate. So again, this is United States. We're not looking at the world. We're talking to ourselves. This is what we can expect to happen under the assumptions that are attached here. And what about what about other aspects? One of the interesting aspects is this notion of nuisance flooding in United States cities, something that doesn't show up in IPCC reports because it's too far down into the detail. But if you live in Charleston, South Carolina, or San Francisco, California, it's in your neighborhood. And it's not necessarily killing people, but it's a nuisance. And it changes the way communities live. And so that's the picture on the right there. We still see two gentlemen walking down the sidewalk, but on the other hand, the street has 1 or 2 feet of water in it. And here are the projections, where these different colors are the different RCPs, representative concentration pathways, as they're called. The dark red is business as usual, where we continue to emit fossil fuels at the rate we're emitting today to the end of the century. And in Charleston, South Carolina, as well as San Francisco, under those circumstances, nuisance flooding will be a fixture. It will occur every day in these communities. And indeed, if you look at the orange down there for Charleston in this last year, they've already had a month of the year in which nuisance flooding was present. So again, this medical checkup analogy, this is what's going to matter to communities. And we have this scientific basis now where we can project and tell communities what they might expect. Okay, so I'm going to shift gears. I'm going to show you one more figure from the report, but I want to start with this graph. This is one of my favorite graphics to show all kinds of people, in particular young people. It's the climate change building, Earth's Grand Challenge. I urge you to type climate change building into your browser and it will pull up this figure in different languages. And you see the top features up there, adaptation and mitigation. The climate change building is what we are doing as a society to support, define what adaptation and mitigation mean to us. It's a very clever graphic. I urge you to study it. The 4 parts that stand out there are science, economy, society, and law and governance. Any climate change building has to have those dimensions to it. And this is kind of what our climate change building looks like today. It's not finished. And that same building there will be a climate change building, I assert, 100 years from now, but we don't know what it's going to look like. Is it going to look like this, or is it going to be a gleaming skyscraper? We don't know. The people in this room are part of the solution to that, particularly the young people. So I am squarely on the science side. Where's science? It's at the bottom. It's the foundation. It's not the shiny glass structure of a high-rise. It's holding everything up. And that's really our mission. As I said with the Climate Science Special Report, there are no policy recommendations. Building the foundation does not mean we know what should go on in these upper stories. So that's why I show here the Climate Science Report is part of this foundation. We don't know how it's going to be used, but we know it will be used, and we think it should be used as part of the foundation. And indeed, when I was asked to spend 2 years writing this report, the reason I said yes is because I knew it would be part of the climate science foundation for the country and indeed the world. And so from this group's point of view, where are you on this graph? Well, you exist there in this alternative energy component between science and the economy. And so everybody has a spot here. And what happens with alternative energy, in particular solar, will have a lot to do with how this building evolves in the future. Okay, so I'm almost running out of time here. This graph I wanted to put in front of you. It's rather new. It comes from Jim Hansen, the famous climate scientist now retired from NASA, showing with some good data sources here what energy usage will be in gigaton oil equivalent up till present, or what it has been up to present, showing this very sobering view that current energy usage is dominated by fossil fuels. You all know that. and you know about that green circle, that there's not a whole lot of solar influencing our world at the moment. And we also know that 2 degrees C is this dangerous interference limit with the climate system, and that a 1.5 to 2 degrees C pathway requires a steep change in this energy. Indeed, it's very steep, that if they want to stay on a 1.5 or 2 degrees pathway on this same scale, these fossil fuel sources that emit CO2 to the atmosphere simply have to go to zero. And so this is the daunting challenge, and this is kind of our marching orders. If you want to change the world, this graph has to change. So one more graph, it's perhaps a little complicated. It's in chapter 14 that I also helped write in this assessment about climate change mitigation. It's a figure out of a science paper. It's just a 2-page paper that you might look at that talks about emission pathways. The vertical is global CO2 emissions from energy and industry as a function of time. And those thick blue lines are basically pathways. We will be on one of those pathways or something related to it. The upper two are business as usual, where we just keep on doing what we're doing. And on the right there, it talks about temperature probabilities. A little complicated graph, but there's no gray there, which would indicate there's probability to stay on 1.5 or 2 degrees C. It's only when you get to the lower pathways. The middle horizontal one there is saying that Paris works and that we keep doing Paris until the end of the century. The lower one is we do Paris and then we enhance it and we have increased ambition. And now you see in the lower right there, you start to get probability from this ensemble modeling paper assessment that will stay below 1.5 degrees C. And indeed, that blue zone that's labeled there, greater than 50% chance for 2 degrees C, it covers a range there because we have a lot of uncertainty. But you see it's on the lower part. 1.5 would even be more stringent there. And I urge you to watch for this IPCC special report on global warming of 1.5 degrees C that's almost reaching completion. It'll be out later this year, that puts this in really stark relief. There's 3 features here. One, we need, if you want to stay on 1.5 or 2, we need to start doing things soon to level off and go on one of these lower pathways. 2, it's a steep decline. Every year we have to have less net emissions to the atmosphere. And 3, by mid-century, particularly for 1.5 degrees C, we have to cross that zero line, that red dashed line, that says emissions have to become negative. Not only do we have to reduce what we've been emitting, we have to start taking out of the atmosphere what we have already emitted. And that's something that I think the world just hasn't come to grips with, that there's no proposals to go negative at scale that have any credibility in today's world. So another canonical graph, and you and your grandchildren and their children will be on one of those paths, and what we do today will determine which one that is. Okay, if I can indulge the chair with one more graph, and that's the dark side, climate engineering, I think is relevant to this group. You can go look at the National Academy that said there's only one way to cool the Earth quickly, and that's with albedo modification of the stratosphere, meaning you inject sulfur like volcanoes. From the scientific side, that bottom box, I'm investing in my scientific world into learning what does that mean scientifically, which is very different than promoting it as an action. For solar energy use, reduction in Earth's temperatures by albedo modification will change the ratio of diffuse to direct radiation, which matters everything in your world. Concentrating solar collectors, their yields will be reduced in a world in which we're geoengineering the stratosphere, and one study suggests 6% will be lost from solar collectors for a 1 degree reduction in Earth's temperature from injecting sulfur. So this is just a flag that I raise that this is coming to the extent that we stay on one of these higher pathways. The only way to keep the Earth cool will be to geoengineer it, at least temporarily. Volume 2 of the climate science report, here's an advertisement This is almost a 2,000-page report. It's a highly, highly detailed medical checkup of the nation's climate. I urge you to watch for that. Look up your section of the world. The Climate Science Special Report is Chapter 2 there, where we took our 500-page report and shrunk it into a chapter. Takeaway thoughts: climate of the U.S. is changing in important ways, and it's projected to continue to change. Solar energy, from my point of view, is an important resource to achieve carbon neutral global energy in the coming decades. The NCA4 Climate Science Special Report is a valuable resource for those who want to understand the nation's climate, present, and future. Volume 2 is coming. I urge you to look at it. Climate Change Science Building illustrates how science, the economy, society, law, and governance need to work together to affect climate change mitigation and adaptation. Thank you for your attention.
Sir, there are many environmentalists who are very against the United States even looking at geoengineering. We're afraid that it will, if we look at it, it will become a potential reality. How do you address that?
I think that's actually hindering our understanding of geoengineering. So you're right, geoengineering is an emotional topic, and as I just pointed out here, it touches all aspects of our society. And without a law and governance framework for geoengineering, we will basically be in this confused, foggy state about whether we should do it or not do it. Wearing my science hat, I say, whether we do it or not do it, we need to understand what it is. And if you look at these graphs and the probability that we're going to stay on the pathways that will protect 2 degrees C, one can deduce that we are almost certainly going to try to geoengineer. I just kind of play out the logic. And so whether it's a good thing to do or not, that's a value judgment. And society hasn't decided how it's going to do that value judgment. So I would say we're behind in addressing this as a combined science, value, ethics, law, and governance, because we've said, oh, if we talk about it, that means we're going to do it. So it's like not discussing the medical condition you have because you're afraid of the treatment, or you're afraid that that's going to change your life in ways you don't want to. So I'm for embracing this. And again, science can only do its part. What I look forward to is the rest of the world creating the governance structure that I add my science to.
I just want to ask you about, this is a fascinating study, and it really should be what we use for the discussion. Those 13 agencies that you talked about that are part of this are being deconstructed, and we are removing ourselves, on purpose, as away from the conversation. I just want you to comment on how we can use this study and continue the conversation so we don't lose that continuity.
Well, a good point. I mean, that's why I commented that this is a, quote, valuable report. And the way it's going to become valuable is if people like here in the audience use this report, print it out, take it to your meetings, show it to your friends, email it, etc. Because you're right, there's kind of a deconstruction going on and things are backing up. But I guess you can note the ambiguity here that these 13 agencies have said yes. And so the backing up, I think, is a little bit of theater at the moment, because if you go down into the cores of these agencies, like mine, for example, they get it. They know what the deal is. They know where the future's going. In my world, I'm a steward of the atmosphere and oceans that is serving society. And if you want to do that well, you want to know what the right answer is. And so it doesn't matter what the politics are, we want the right answer. So my encouragement to you, the answer to your question is, use this report as much as you can. Disseminate it, refer to it, cite it in your work, and refer to the quality of this report. This is the government talking to the nation. Thank you.
Thank you.